students, welcome all of you. Today we will continue with dimensional analysis and few more quantities which are remaining. Let's see. First one, momentum. Momentum in 9th class you have seen. See, what is the symbolic difference between momentum and pressure? For pressure we use capital P. For momentum, small p. Okay. So momentum is mass into velocity. Mass into velocity. So its unit will be kg meter per second. Kg meter per second. Mass kg. Unit of mass is kg and unit of velocity is meter per second. So this is the unit of momentum. So what will be the dimensions of momentum? What are the dimensions of momentum? See, for kg is mass, so it can be written as m. Meter is for length, so it can be written as L. तुम्ही power 1 लिहू शकता. Per second means upon second. Second is for time. Now, if you simplify this, m to the power 1 can be written as m, n to the power 1 can be written as L, and t to the power 1, when it goes to numerator, it will become power minus 1. So we can write t to the power minus 1. So these are the dimensions of momentum. Next one, impulse. Actually, impulse is f dot dt. F dot dt. म्हणजे it is the integration of force. Integration of force. So tell me, the differentiation of momentum is nothing but force from Newton's second law. From Newton's second law, rate of change of momentum per unit time, rate of change of momentum per unit time is force. That means differentiation of momentum with respect to time is force. That means integration of force is momentum. Differentiation of momentum is force. That means integration of force is momentum. Vice versa. आपण बघितले differentiation मध्ये बघितले, integration मध्ये बघितले. ठीक आहे? Differentiation of momentum is force. That means integration of force will be momentum. So it can also be written as change in momentum. किंवा इथं बघा, हे जर क्रॉस मल्टिप्लाय झालं तर काय होईल? ठीक आहे? Actually this is from second law of motion, Newton's second law of motion. काय Newton's second law of motion? Rate of change of momentum is equal to net force. So when this dt multiplies here, what will happen? F into dt, and F into dt is what? Impulse. So F into dt, जर हे dt कडे गेलं तर काय होईल? dt change in momentum. So that means impulse is nothing but change in momentum. That means impulse and momentum have the same unit and same dimension. So what is the unit of this? Unit will be kg meter per second and dimensions will be again same. mlt minus 1. mlt minus 1. Okay. So make a note of these two quantities. Next one, kinetic energy, potential energy and work we have seen. mgh is the potential energy and kinetic energy we have seen. That is what? Work we have seen. Work is analogous to potential energy. Now kinetic energy, बघा तुम्हाला एनर्जीचं जे डायमेन्शन आहे, जे पोटेन्शियल एनर्जीचं किंवा वर्क और टॉर्क, पोटेन्शियल एनर्जी, वर्क, टॉर्क ह्या तिन्हीचे डायमेन्शन आपण एकच लिहिलेले आणि तेच कायनेटिक एनर्जीचे यायला पाहिजे. बिकॉज इट इज अ फॉर्म ऑफ एनर्जी. एव्हरी एनर्जी, हीट, एनर्जी सर्वांचे डायमेन्शन्स काय असतात? सेम. व्हाट इज द फॉर्म्युला फॉर कायनेटिक एनर्जी? इट इज हाफ mv². हाफ mv². So the unit wise बघितलं, what is the unit of mass? kg. What is the unit of velocity? It is meter per second आणि त्याचा स्क्वेअर, meter per second square. So what will be the dimensions? Kinetic energy dimensions will be, for kg we can write m to the power 1, because kg corresponds to mass. Then meter square meter is corresponds to length, so we can write l square upon second corresponds to time, so dimension is t, so t square. And when we simplify this m to the power 1 can be written as m l square, and when this t to the power 2 goes to numerator, it will become t to the power minus 2. So these are the dimensions of kinetic energy. So have a look. In previous lecture, what we have derived the dimensions for work, then potential energy, that is energy, and torque. So you will find the same dimensions over there. Here's dimensions to multiple sthiti, because kinetic energy is also a form of energy. So these are remaining dimensions. Now we'll see dimensional analysis. Dimensional analysis. So in dimensional analysis, we are going to see what are the applications or what are the uses of dimensions. ठीक आहे, जे काय आपण डायमेन्शन्स बघितलं तर त्या डायमेन्शनल एनालिसिसचा यूज काय होणार आहे हे आपण पाहणार आहोत. लेट्स सी the first use or first application to check whether the given equation is homogeneous or not. To check whether the given equation is homogeneous or not. So in which we have to see whether the given equation is homogeneous or not. बघा, एखादं इक्वेशन होमोजेनियस असेल तर आपण ते लिहू शकतो. फॉर एक्झाम्पल, from now we are in Kolhapur, so from Kolhapur to Pune it is 200 kilometers, and from Pune to Mumbai it is 100 kilometers. So what is the total distance? So one student will tell 200 kilometer plus 100 kilometer will be equal to 300 liters or 300 kg किंवा 300 डिग्री सेल्सियस. असं होईल का? नाही होणार ना. काय होणार? 200 किलोमीटर प्लस 100 किलोमीटर विल बी इक्वल टू 300 किलोमीटर्स. किंवा 2 apples plus 1 apple, 200 apples plus 100 apple will be equal to 300 mangoes होईल का? 300 is correct, but 300 काय असणार? apples होणार. ठीक आहे. So that means dimensions of each and every term on LHS should be equal to dimensions of each and every term on RHS, and that type of equation is called homogeneous equation. And to write any equation, to write any formula, the equation must be homogeneous. ठीक आहे. कोणताही फॉर्म्युला, कोणतेही इक्वेशन आपल्याला लिहायचं असेल तर that must be homogeneous. That means dimensions of each and every term on LHS must be equal to dimensions of each and every term at RHS. And that is called homogeneous equation. So to check the given equation is homogeneous or not, we use dimensional analysis. Next, to establish relation between given quantities. For example, तुम्हाला मी सांगितलं एक कायनेटिक एनर्जी आहे, एक मास आहे, एक वेलोसिटी आहे. नाउ एस्टॅब्लिश द रिलेशन. सो तुम्हाला तर ह्याचा रिलेशन माहिती आहे. सो कायनेटिक एनर्जी इज इक्वल टू हाफ ऑफ mv square. So we can say kinetic energy is proportional to mv square. So we can tell that this kinetic energy is proportional to mv square. हे तुम्हाला माहिती आहे. पण माहित नसेल, if you don't know, if you doesn't know what is the relation between these three quantities, then we can find the relation using dimensional analysis. Okay, relation between any quantity. So you will be given the three quantities and using the dimensional analysis we have to find this. Okay, exact formula we couldn't find. हाँ exact formula find होना नहीं, but at least relation find होना. Relation क्या है? Kinetic energy mv square च्या proportional है. Okay, next one. Conversion of units. Conversion of units. Now, most of you know how to convert the unit, like 1 meter is equal to 100 centimeter, or 1 meter is equal to 1000 millimeter, or 1 kilometer is equal to 1000 meter. Okay, 1 kilogram is equal to 1000 gram. So, basic, if you know basic conversions, then we can find the difficult one conversions, like how many dynes is equal to 1 Newton, because Newton is the unit in SI units. This is the unit of force in SI system of units, and this is equal to 10 raised to the power 5 dyne. Or see 1 joule is equal to 10 raised to the power 7 erg. Now this dyne and erg, dyne is the unit of force in CGS. What is CGS? Centimeter, gram and second. CGS system. Centimeter, gram and second. So this is dyne. Dyne is the unit of force in CGS, and erg is the unit of energy in CGS. Now this is actually you don't have the correct value. मुझे तुम्हारा ये मालूम नहीं, but basic values you know, like how to convert meter into centimeter. So on the basis of basic values and dimensional analysis, we are going to find what are the conversions of different quantities. ठीक है? So जगह माहिती नसते लक्षात. So these are the uses of dimensional analysis. So one by one we will see. The first one, to check whether the given equation is homogeneous or not. So what is the definition of homogeneous equation? Dimensions of each and every term at LHS should be equal to dimensions of each and every term of RHS. So, first of all, I will take the equation. You know what is the kinematic equation? First kinematic equation, that is V is equal to U plus AT. V is equal to U plus AT. Now, okay, at LHS. LHS ना कौन है? Velocity. What is the dimensions of? What are the dimensions of velocity? L t minus 1 meter per second. Now in this per second म्हणजे upon time. Distance म्हणजे L upon time t. When this t comes to numerator, it will become minus t. This is the dimensions of LHS. Now at RHS. Now this should be the dimensions of each and every term of RHS. Then the equation will become homogeneous. Now RHS we have two quantities, U and AT. So first of all we will see for U. U is again initial velocity. This is final velocity. So as both are velocities, the dimension will be same, LT minus 1. Okay. U is the same. Yeah, the one the same. Now we will see about AT. AT. What is AT? A into T. What is A? A is acceleration. What are the dimensions of acceleration? Acceleration जो यूनिट का है मीटर पर सेकंड स्क्वायर. meter per second square, that means LT minus 2. LT minus 2 meter per second square. When that second square, that is time square, that is t square, and when that t square comes to numerator, it will become minus t to the power minus 2. Okay, when that t square comes to numerator, it will become t to the power minus 2, and multiplied by t, small t for time, so again multiplied by t. Now see, here L is there and t to the power minus 2 and a single t, that is t to the power plus 1. So minus 2 and plus 1, minus 2 and plus 1, it will become minus 1. So what you can observe here, see, dimensions of all the terms of LHS is equal to dimensions of each and every term of RHS. So yacha पण LT minus 1, yacha पण LT minus 1, yacha पण LT minus 1. So this equation is homogeneous. Okay, homogeneous. This was more equation to you, but because you have studied this equation in 9th class, that's why I have taken this equation. And in fact, it is actually homogeneous and correct. That's why I have taken that equation. Again, you know, second kinematical equation. S is equal to ut plus half at square. Ut plus half at square. Okay. So here, if you want to check at LHS, see which quantity is there? S. S is displacement. So what is the unit of displacement? Meter, and meter corresponds to length. So dimensions are L. Okay. Now this must be the dimensions of these two quantities. This L must be the dimension of these two quantities. Let's see at RHS. At RHS we have UT. First quantity as UT, U into T. What is U? U is the initial velocity. What is T? Time. What are the dimensions of velocity? Atta's pahle. What are the dimensions of velocity? U is equal to dimension of LT minus 1 meter per second. LT minus 1 into this time into T. What will happen? This t to the power plus 1 and this t to the power minus 1 will cancel each other. Because student, tell me, this is u meter per second and time is in second. So this second and in this there is a per second. So second and per second will cancel each other. Only meter will remain. So the dimensions will be L only. L. Now the last quantity 80 square. Don't take half because half is a constant and it doesn't have any dimensions. Half is a constant. So take only 80 square. 80 square. Okay. So what are the dimensions of acceleration? A. Acceleration is meter per second square. That means L t minus 2 meter per second square and multiplied by t square. T for time square. Time square. Now see here there are two powers, power 2, positive to power of t and here negative to power, both will cancel each other. So we are remaining with only L. What we are going to observe? Dimensions of each term of LHS is equal to dimensions of each and every term of RHS. Hence, both the equations are homogeneous. Okay, for you the homework, check the homogeneity of V square is equal to U square plus 2AS. Check this homogeneity. ये homogeneous आहे की नाही ते check करा. Okay, this is the third kinematical equation, and whole this one is the first application of or first use of dimensional analysis. Next we will see second application. Next we will see second application or use to establish the relation between given physical quantities. म्हणजे एक प्रकारे तुम्ही असं म्हणू शकता हम क्या कर रहे हैं यहाँ पे कोई फॉर्मूला डिराइव कर रहे हैं. फॉर एग्जांपल व्हाट इज द फॉर्मूला फॉर टाइम पीरियड ऑफ सिंपल पेंडुलम? इट इज 2 पाई अंडर रूट l by g. ओके 2 पाई क्या है? कांस्टेंट है. व्हाट इज l क्या है? इट इज द लेंथ ऑफ द स्ट्रिंग एंड g it is the acceleration due to gravity. m is the mass and this time period mass पे डिपेंड नहीं करता, ठीक है? इट इज इंडिपेंडेंट ऑफ मास. सो किस पे डिपेंड करता है? स्क्वायर रूट के अंदर लेंथ ऑफ द पेंडुलम एंड एक्सेलरेशन ड्यू टू ग्रेविटी. सो दिस इज द फॉर्मूला फॉर टाइम पीरियड ऑफ सिंपल पेंडुलम. दिस इज टाइम पीरियड ऑफ सिंपल पेंडुलम. नाउ suppose we have the answer, we have the relation, but if you don't know what is the exact relation, okay, and if in the exam or if you want to know what is the exact relation between time कशावर किस पे क्या करता है, डिपेंड करता है what is time period. suppose mass is given, क्या गिवन असता है, कौन सी क्वांटिटीज गिवन होंगी? एक तो लेंथ गिवन होगी, then mass of the pendulum given होगा, then what do you know, length तो given है, mass given है, and then acceleration due to gravity, and you are doing the experiment to find the time period. So practically you can find time period by stopwatch, but you want to establish the formula for the time period based on the three quantities: mass, length, gravity. Okay. So you want to establish or just you want to tell how it varies, like if length increases, how it affects the time period. If we go to any other planet, then how it affects to the time period. That means how length, mass, whether the time period depends on mass or not. In place of small ball, if I place big ball, big stone to this pendulum, okay, what will happen? So for that we know we should have a formula, ठीक है? So only so इथं आपण हा फॉर्म्युला यासाठी लिहिलेला आहे आपला आन्सर बरोबर आहे का चेक करायला, ठीक आहे? So initially what we will have time period, quantities on which तुम्हाला असं वाटतं अशा quantities, हाँ तुम्हें ऐसा लगता है कि इस quantities के ऊपर time period depend होना चाहिए. कौन सी quantities हैं? Time हो सकता है, mass of Bob, planet on which we are doing the experiment, so planet which represents the planet, acceleration to gravity of that planet, acceleration to gravity of that planet. Okay, for Earth it is 10, 9.81, nearly about 10. For Moon it is g upon 6, g divided by 6. It is 6 times less than Earth. So and length. So these are the four quantities. We think हमें ऐसा लगता है कि इस four quantities के ऊपर time period depend हो सकता है. So देखते हैं. So time, mass, gravity and length. So first of all I will write the time period should be equal to mass to the power A, gravity to the power B, and length to the power C. Time period should be equal to mass to the power A, gravity to the power B, and length to the power C. Okay. Then write the dimensions of each term. So what are the dimensions of time? It is T. What are the dimensions of mass? M to the power A. M to the power A. A mention. Okay. What are the dimensions of G? Now see, G is acceleration due to gravity. It is acceleration due to gravity. That means it is acceleration. So what are the dimensions of acceleration? Lt minus 2. Lt minus 2 meter per second square. So I can write Lt minus 2 to the power B. Lt minus 2 to the power B. And length. What are the dimensions of length? L power C. Now see here student, T is given. तो यहाँ पे M नहीं है और क्या नहीं है? क्या गायब है? M and L. So M की power 0, L to the power 0 and T to the power 1. M to the power 0, L to the power 0 and T है. T is single term of T is present, that means T to the power 1. Now see here, M appeared only once. So that means M to the power A. M to the power A. L appeared twice. So that means L to the power B and L to the power C. So I can write L to the power B plus C. L to the power B plus L to the power C. That means L to the power B plus C. And time appeared only once, that is minus 2b. Okay. काय केलं मी इथं m ची पॉवर किती चेक केली, l च्या पॉवर किती चेक केला. l इथं दोन वेळा आला, एकदा पॉवर b आणि एकदा पॉवर c and t ची पॉवर आहे -2 into b. Now just only compare the powers of individual terms. Like see, power of m is 0, here power of a is 0. That means here 0 is there, here a is there. That means a is equal to 0. Compare the powers. Compare the powers. So a is equal to 0. Okay. Now again, which term we can compare? See here, t to the power 1 and t to the power -2b. So we can write -2b is equal to 1. -2b is equal to 1. करते हैं ना? A is equal to 0, -2b is equal to 1, and b plus c is equal to 0. So -2b is equal to 1. That means b is equal to, when this -2 goes to RHS, it will be in denominator. So b is equal to -half. So b will be equal to -half. Now the third comparison of power of L, that is b plus c is equal to 0. So we can write b plus c is equal to 0. When b plus c is equal to 0, c is equal to -b. When this positive b goes to RHS, it will become negative b. Then I will substitute the value of b. What is the value of b? It is -half. So -1 is, minus sign is already there, and again the value of b is -half. Minus will become plus. So c is equal to half. Now we have all the three values. A is equal to 0, b is equal to -half, and c is equal to +half. Okay. I clearly करेगा. First of all, I have assumed powers, different powers A, B and C for the total quantities. Okay. Then I have written all the dimensions. Then I have simplified or I have written the single terms, that is M, L, P, and given the total powers of respective terms. Then I have compared the individual quantities, individual dimensions. Now we have all the three values, A is equal to 0, B is equal to minus half, and C is equal to half. Substitute these values here in the assumed equation. So what will be the new equation? See, P is equal to M. बघा इथे इक्वल टू म्हणण्यापेक्षा आपण प्रपोर्शनल घेऊया, ठीक आहे? प्रपोर्शनल directly proportional. गुणावरती depend, not equal. So now substitute the values. What is the value of A 0. So m to the power 0. Then g to the power b. What is the value of b? Minus half. Then L to the power c. C value c to the power half. L to the power half. Now tell me, when this minus half goes to denominator, this g to the power minus half goes to denominator, it will become plus half. Okay, and anything to the power 0 is 1, so it will become 1. So time period is proportional to L to the power half upon g to the power half. When this minus half goes to denominator, it will become plus half. Now see, when power is half, that means it is square root. Power जब आधा होता है, जिसका मतलब क्या है? वो square root, ठीक है ना? Square root of L and square root of G. So T is proportional to under root L by G. So see, as per the formula, we have established the relation between T and root L by G. And what is 2 pi then? 2 pi is the proportionality constant. Proportionality constant, like in Ohm's law. Ohm's law क्या करता है? V is proportional to I, voltage is proportional to current, but V is equal to IR, and R is the proportionality constant, that is resistance. Okay, so this 2 pi, scientists found out that 2 pi by experimental value is 2 pi to equate this equation. But we have established the relation, that is time is proportional to square root of length. So that means if length of pendulum increases, time will also increase. Length of, what are the conclusions? What are the conclusions we can make? So if length of pendulum increases, see, time is directly proportional to length. Somewhere है ना? Time is समोर length है. In front of time there is length. So that means if length of pendulum increases, time period will increase. Time period to complete. Time period म्हणजे काय? Starting from one extreme, mean, negative extreme, mean, positive extreme. This is the complete cycle. Starting from this extreme, again returning to that extreme. Okay, so this is the complete one cycle. From this extreme to this extreme position, it is half cycle. Okay, so to complete one rotation, to complete one cycle, the time required is called period of pendulum. So this period depends on length. जितकी जास्त लेंथ असेल तितका काय टाइम पिरियड जास्त लागणार आहे, आणि दिस टाइम पिरियड इज इनवर्सली प्रोपोर्शनल टू स्क्वेअर रूट ऑफ g. Inversely proportional to square root of g means if g is smaller, time period will be greater. So on moon, g is smaller. On moon it is 1/6 of gravity on earth, gravity that of earth, that is g by 6. So gravity reduces on moon, it is having smaller value as compared to earth. So that means on moon the time period will be greater. So as g decreases, so we can say as L increases, time period will increase, and as g increases, time period will decrease. Inversely proportional, right? So length increase, time increase. But g increases, time period will decrease. And time period is independent, याचा काहीही संबंध नाही, independent of mass. मास आहे का इथं कुठं इक्वेशन मध्ये m to the power 0 झालेलं आहे. m to the power 0 because value of a is 0. So m to the power 0. So तुम्ही कितीही मोठा मास लावला, it will not affect और कितीही छोटा मास लावला. So mass of bob of the pendulum, time period of pendulum is independent of mass of the bob of the pendulum. ठीक है? So this is the second application to establish the relation between given physical quantities. Next, we'll see third application of dimensional analysis. Third application, that is conversion of units. Conversion of units. Third application. So here we are going to convert. For example, if anybody asks you what is the CGS value of 1 Newton, we know its unit is dyne in CGS, but 1 Newton is how much or how many dynes? Our CGS unit of energy is urge or earth. So 1 joule is equal to how many earths? So we will convert this. We know basic quantities, okay? That you must know: centi, deci, milli, kilo. Okay. Now, what you have to write? First, write the dimensions. For example, we have to find 1 Newton is equal to how many dynes. Okay. So, first write what are the dimensions of force. What is force? Force is mass into acceleration. Mass into acceleration. That means dimension. Mass for m and acceleration Lt minus 2 meter per second square. Lt minus 2. Mass into acceleration. Mass into acceleration. kg meter per second square. हिंदी का भी लोग देख चार बोर्ड में बताता है, हाँ? हम लोग देख चुके हैं kg into meter per second square. So this is what dimensions of force. So first of all, write CGS dimensions. So force in dyne, or we can say here CGS upon SI. So force in dyne upon force in Newton, or we can say here dyne upon Newton is equal to, इथं पण आपण लिहूया mLt minus 2, इथं येणार CGS upon mLt minus 2 in SR. Now write this as it is, dyne upon Newton. और वाइस वर्सा आपण उलटा पण करू शकतो. उलटा म्हणजे असं करूया, फोर्स इन न्यूटन अपॉन फोर्स इन डाइन इज इक्वल टू न्यूटन अपॉन डाइन असं लिहिलं तरी चालेल युनिट मध्ये. 1 न्यूटन अपॉन 1 डाइन. Now here we can write these dimensions mLt minus 2 in SI upon mLt minus 2 in CGS. Now carry forward this, 1 Newton upon 1 dyne is equal to. So SI unit मध्ये याचा व्हॅल्यू युनिट्स आपण सबस्टिट्यूट करू. What are the units of mass in SI unit system? Kilogram. into what are the units of length, meter, into time to the power -2 म्हणजे second to the power -2 second, time दोन्ही मध्ये सेकंड असतं CGS आणि SI upon. Now here in CGS मध्ये मास काय आहे, मास किती आहे, कशामध्ये असतं CGS मध्ये, ग्राम, लेंथ सेंटीमीटर. CGS itself says सेंटी, ठीक है ना, क्या है, ग्राम एंड सेंटीमीटर, ग्राम एंड सेकंड, सेंटीमीटर, ग्राम एंड सेकंड. So here also second. Okay, this seconds -2 second -2 cancel each other because in both the system unit of time is second. Now just we have to convert this. Either you convert this kg into meter into CGS or convert this into SI. दोन्ही पैकी एकाला कन्वर्ट करा, दोघांना कन्वर्ट करा. So let's see what will happen. 1 Newton upon 1 dyne is equal to kg. 1 kg can be written as 1000 gram and 1 meter can be written as 100 centimeter upon gram into centimeter, upon gram into centimeter. Okay, now see, gram cancel, centimeter cancel. Now we are remaining with 1 Newton upon 1 dyne is equal to 1, 2, 3, 4, 5. It will be 10 raised to power of 5. Multiply this dyne here, we'll get 1 Newton is equal to 10 raised to power of 5 dyne. So this is how we have converted the Newton into SI units, that is dyne. For you, the homework will be convert 1 joule is equal to 10 raised to power 7 H. This is the answer. Actually, I have given you the answer itself. 1 joule is equal to 10 raised to power 7 Earth. So this is the unit of energy, and I have given the dimensions of energy in the table in last lecture. Whole chart I have given you. What are the dimensions of energy and all. So this is your homework number 2. First homework I have given you, v square is equal to u square plus 2s. Then you have to check whether the equation is homogeneous or not. Okay, so this is a dimensional analysis. Next we will see what are there are some units we have finished. Now during measurement, of quantities, some errors may happen. So what are the types of errors that we are going to see, and how to calculate the errors? So there are basically two types of errors. Okay, basically two types of errors. First one, systematic errors, and second one, random errors. What is meant by error? You know, error म्हणजे fault or त्रुटि, fault. So error means suppose you have to measure some distance and it should be 50 centimeter or 40 centimeter, but reading appears to be 39 point something. 40 reading आला पाहिजे होता पण reading 39 point something आला or 40 point something आला, म्हणजे plus or minus 40 आला पण exact 49 आला. So that means there is a error of some value. Suppose in place of 40 the reading is of 41. So that means 1 centimeter of error occurred. Okay. So systematic errors are again of three types, which are instrumental error, instrumental errors, then personal errors, and errors occurred due to inaccurate method of experiment. And the third one, personal errors. Now these three are called systematic errors because we can completely eliminate or minimize the errors. But the random errors are which are caused because of external factors. Random name itself says we don't know why or what is the reason behind it. Why this errors has been caused. So it may depend on temperature, pressure, or atmospheric conditions, or mechanical vibrations. So lots of the factors depend. So temperature, pressure, vibration, humidity, or dust. So lots of external factors are there which causes the errors and which are unavoidable. ते आपण अवॉइड करू शकत नाही. प्लेस टू प्लेस ते व्हॅरी होणार. फॉर एक्झाम्पल एखादा मेटल आहे, कंडक्टर आहे, तुम्ही राजस्थान मध्ये जाऊन एक्सपेरिमेंट केला तर त्याची लेंथ इन्क्रीज झाली. और सहारा डेजर्ट, in Sahara desert if you conduct the experiment you will get the more length, but if you do the same experiment in Russia or Greenland you will get lesser length. Why? Smaller length, because there will be thermal compression, and in desert area you will get thermal expansion. So this is because of, but that is not the actual length. Okay, so this is because of the temperature. Or if you want to measure volume or pressure of some liquid, then at different places, at like Mahabaleshwar or that what we call coal station, you will get lesser pressure or smaller pressure. But when you go to seashore on beaches, okay, at sea level, you will get more pressure. So the reading will vary as per the place and as per the atmospheric conditions. So that are the errors caused in measurement, which are random errors. ठीक है ना, random errors करें, and these errors are unavoidable. We can't eliminate this error completely. So these are avoidable. Okay. Next point, can completely eliminated म्हणजे आपण ते काढून टाकू शकतो. हे काय अनअवॉइडेबल, आपण यांना अवॉइड करू शकत नाही आणि ते येणारच आहे. आणि can't be completely eliminated. Just we can minimize. Just we can minimize the errors. So आता आपण बघूया one by one. इकडे तर काही प्रॉब्लेम नाही आहे. So these are the random errors caused due to various atmospheric conditions or sudden change in atmospheric conditions. ठीक है. And here these errors are unavoidable. ते कसे कुठे येतात? We don't know the exact cause of these errors, and these errors are we can't completely eliminate these types of errors. Just we can minimize the errors. But here these types of errors are avoidable and can completely eliminated. Now we will see the three types of systematic errors one by one. The first type, instrumental errors. हे सगळे पॉइंट लिहून घ्या आणि त्याच्यामध्ये डिटेल तुम्ही हे करा, सेल्फ स्टडी करा आणि लिहून पण घ्या. इन्स्ट्रुमेंटल एरर्स काय असतात? आता इन्स्ट्रुमेंटल एरर बघा, सपोज तुम्ही थर्मोमीटर आहे, टेम्परेचर चेक करायचं. मग एका पर्सनचं चेक केलं, एका पर्सनचं चेक केल्यानंतर after checking the temperature of one person you will get some reading, then the mercury should go down to 0 scale for checking the next person. Suppose एका पर्सनचं रीडिंग 100 आलेलं आहे, 100 डिग्री फॅरेनहाइट, आणि ते परत फॉर चेकिंग द सेकंड पर्सन you have to lower down the mercury, and as mercury approaches 20 degrees Celsius, as mercury approaches 20 degrees Celsius, if you insert the thermometer to the second person, and suppose the second person is having temperature of 100 degrees Celsius, so what will happen? 20 degrees Celsius plus 100 degrees Celsius, the thermometer will show 120 degrees Fahrenheit. Thermometer will show 120 degree Fahrenheit. Actually, the second person is having 100 only, but you have started taking reading from 20. You have not reset the thermometer to absolute 0. आपण काय केलं, ऍब्सोल्यूट 0 थर्मोमीटर सेट केला नाही. पहिल्या पर्सनचं चेक केलं 100 होतं, 100 झाल्यानंतर 100 नंतर तो थर्मोमीटर लोअर व्हायला लागला, अप टू 20 आल्यानंतर लगेच सेकंड पर्सनचा थर्मोमीटर यूज केला. सो सेकंड पर्सनचं टेम्परेचर पण 100 असेल, सो ते कुठून 20 पासून अगेन 100 डिग्री होणार. सो टेम्परेचर विल बी 120 डिग्री फॅरेनहाइट. ते टेम्परेचर बघितल्यानंतर तो तापाने नाही, फिवर नाही, हार्ट अटॅकने करून जाईल की माझं टेम्परेचर 120 डिग्री फॅरेनहाइट झालं, जे की नॉर्मली 104 105 ला काय असतं, हाय फिवर म्हणतो. 110 ला जर म्हटलं तर आपण कोरोना म्हणतो. कोरोनाला किती असतं, 110 च्या आसपास जातो. 120 म्हटल्यानंतर हार्ट अटॅक मध्ये बघूनच. सो यू हॅव टू सेट द ऍब्सोल्यूट 0. कळलं? even though if you are taking the reading with a scale, and if you have started from in between, then you should know how many length of scale you have eliminated. तुम्ही किती स्केल सोडली आहे ती सोडून तुम्ही किती डिजिट्स पुढे ऍड करायला पाहिजे. तुम्ही जर 5 सेंटीमीटर पासून चालू केलं and reading is 100 centimeter, so it is not 100, it is 95, because 5 you haven't started from 0 centimeter. Okay, so this is instrumental. Next, errors occur due to inaccurate method of experiment. Now inaccurate method of experiment म्हणजे काय? सपोज ही बॉटल आहे, कंटेनर आहे, याच्यावरती काय लेवल मार्क्स आहेत आणि याच्यामध्ये किती वॉटर आहे ते आपल्याला चेक करायचं आहे. आणि इथं आता मेन्शन आहे 1 लिटर, ह्याच्यावरती 1.5 1.6 असं रिडिंग आहे. आणि तुम्ही जर बॉटल अशी धरली तर काय दिसणार आहे, हे वॉटर वरती जाते ना आणि रिडिंग जास्त दिसणार आहे. सो दिस इज इनॲक्युरेट मेथड. यू हॅव टू होल्ड वर्टिकली. ओके, then only you will get the correct reading. If you hold the test tube in inclined position, if you hold the test tube in inclined position, you will get more reading, and which is inaccurate. And this error was due to inaccurate method of experiment. So this is also you can eliminate. आपण eliminate करू शकतो. ठीक आहे ना, eliminate करू शकतो म्हणजे पर्सनला सांगू शकतो बाबा तू नीट एक्सपेरिमेंट कर, व्यवस्थित कर. इन्स्ट्रुमेंटल एरर सुद्धा आपण हे करेक्ट करू शकतो. नेक्स्ट, पर्सनल एरर्स काय असतात? पर्सनल एररचं मोस्ट कॉमन एक्झाम्पल इज पॅरलॅक्स एरर. पॅरलॅक्स एरर मीन्स इफ यू हॅव स्केल मेड अप ऑफ ग्लास, काचेची पट्टी आहे, and while taking measurement you have to look from up to down like this. If you are taking the reading like this, then you will not get correct reading. Because of refraction you will get inaccurate reading. So to get exact reading you have to look from top view. खाली पेपर आहे, पेपर वरती स्केल आहे आणि स्केलच्या वरून तुम्हाला बघायचं आहे, and then only you will get the true reading. If you if paper is placed on the bench, your table, and on that scale is placed, and if you are looking at the parallel level, you will get the parallax error because of refraction of light. Okay, and you will get different reading. So do that in your home again an experiment. करू शकता तुम्ही होम लेवलला घरी की तुम्ही त्याच्यावरती 5 सेंटीमीटर मार्क करा असं पुट करून आणि परत वरून बघा ते 5 सेंटीमीटर किंवा 10 सेंटीमीटर असणार त्यामध्ये एरर येऊन जाईल. ठीक आहे. So this is personal error. So this is about errors. Now these are the types of theoretical errors. Theoretical errors. But to calculate mathematically, we have different few terms. बघूया आपण कोणते टर्म्स आहेत. So what is error? Error is actual value minus measured value. Error लाच आपण म्हणतो bias. It is also called bias. Actual value minus measured value. बघा actual 40 सेंटीमीटर यायला पाहिजे होती, तुमची 39 सेंटीमीटर आली. कितीचा एरर आहे? 1 सेंटीमीटर. Because 40 minus 39, actual minus measured. Okay, so this is error. Now काय करायचं आहे? And to eliminate the errors, we have to repeat the experiment. कारण का फर्स्ट एक्सपेरिमेंट आपण केला आणि रीडिंग 39 आलं and you don't know whether your reading is correct or not. तुम्हाला ऍक्च्युअल रीडिंग माहितच नाही किती 40 48. तर तुम्ही काय करणार? एक सेव्हरल रीडिंग्स घेणार, 4 readings or 5 readings. Repeat the experiment. Then you will get the different readings and then take the average of that. Okay, मग काही above 40 येतील, काही below 40 असतील. And when you take the average of all the readings, you will get the approximate value near to the actual value. Okay, now let's see, while conducting the experiments, A1, A2, A3, AN are the readings. These are the readings. Now in 10th class you have studied what is the mean value of the readings. What is the mean value? It is sigma AI from I is equal to 1 to n. What is the meaning of this? A1, sum of all the terms divided by number of terms. Divided by number of terms. This is called a mean value. Then we are going to find. See, if first you have conducted experiment, you have the value A1. After in second experiment, we have the value A2. Subsequently, as we go on conducting the experiment, we are getting different values. So as we are getting different values, we have taken the mean of all the values to get the approximate value which is near to actual value. And mean we have taken. Then we are checking how all the readings are deviated from the mean. हा मीन समजा आपण काय म्हणतो, हे मीन जे व्हॅल्यू आहे ती काय ऍक्च्युअलच्या बरोबर असणार आहे असं म्हणतो. म्हणजे काय, A1 पहिल्यांदा एक्सपेरिमेंट केलं, A1 व्हॅल्यू भेटली. सेकंड टाइम एक्सपेरिमेंट केलं, A2 व्हॅल्यू भेटली. असं आपल्याला AN व्हॅल्यू भेटली. मग कोणी म्हणतात प्रत्येक व्हॅल्यू मध्ये थोडा थोडा एरर असणारच आहे. मग काय केलं आपण, सगळ्यांचं मीन घेतलं आणि मीन व्हॅल्यू अशी हिला साजून केलं आपण की ऍक्च्युअलच्या अप्रॉक्सिमेट जवळ असणार. चला आपण ऍक्च्युअल म्हणू. मग ही जर ऍक्च्युअल असेल, actual minus measured. आताच बघितलं आपण actual minus measured म्हणजे काय, error. So absolute errors delta A1 म्हणजे काय, modulus of A mean minus first reading. मॉड्युलस म्हणजे काय, याच्या आतमध्ये निगेटिव्ह जरी आलं तरी आन्सर पॉझिटिव्ह असायचं. ॲब्सोल्यूट एरर हा फर्स्ट ॲब्सोल्यूट एरर. देन ॲब्सोल्यूट एरर ऑफ सेकंड रीडिंग म्हणजे काय, ॲक्च्युअल रीडिंग ॲक्च्युअल व्हॅल्यू minus measured value. This is the measured value of second experiment. Then delta A3 actual value minus measured value. This is the measured value of third experiment. Now same way, delta An, that is actual value minus measured value, that is An. So these are the actual values. A mean is the actual value. Why? We have taken average or mean of all the incorrect value, all the incorrect value or all the measured values, and we have assumed if you take the mean, it should be near to actual. So that means it is actual, and actual minus measured is error. So these are the absolute errors. Then if I take mean of all the absolute errors, it is called mean absolute errors. Mean absolute errors. Mean absolute errors is mean of all the errors. So it will be delta A mean. Mean of all the absolute errors, that is delta A1 plus delta A2 plus delta A3 up to delta An upon n. This is mean absolute error. Okay. Now this mean absolute error, how it deviates from the mean value? This is the mean error. We have found out different errors. How the first experiment, how the error of first experiment, or how the value of first experiment deviates from the exact value. How the value of second experiment deviates from the exact value. So these are the different errors of different experiments. Now I have taken the average of all the errors. So that means it is the average error. Now how the average error deviates from average value, that is A mean, and that is called relative error. Relative error, which is nothing but relative error, which is delta mean absolute error upon A mean. Mean absolute error upon A mean. Okay, and last one, percentage error. Percentage error, that is relative error into 100. A mean, delta A mean, mean absolute error upon mean value into 100. So this is percentage error. So very important. जे आज बोर्ड में लिहिलेलं आहे ते खूप इम्पॉर्टंट आहे. ठीक आहे. So error म्हणजे काय? Actual value minus measured value. Then A1, A2, A3 are what? Measured values of all the experiment. Then I have taken average of all the values to get actual value or approximate actual value. Then actual value, that is mean value minus individual values, are absolute errors. Then I have taken mean of all the absolute errors, that is mean absolute error. Then mean absolute error upon mean of all the values is called relative error. If I multiply the relative error by 100, it will be percentage error. Okay, write down everything. So numerical based on this we will see in the next class. Now just we'll see how the errors depends on the other functions, like see, suppose z is equal to a plus b, then error in z, this is the error in z, related error in z is equal to error in a plus error in b. Okay, multiplication असेल तर इथे काय होणार आहे आपण सम असेल तर इथं प्लस करणार आहे, प्लस और माइनस जे काय असेल ते. ओके, नाउ इफ even if z is equal to a into b or z is equal to a divided by b, then also z delta z upon z, error in z is equal to error in A plus error in B. Okay, make a note, very important. ठीक है, प्लस माइनस असू दे किंवा प्रोडक्ट असू दे किंवा डिव्हिजन असू दे, फॉर एव्हरीथिंग द एरर इन z is equal to error in A plus error in B. Suppose like this it is given z is equal to a cube. So what will happen? See, z is equal to, we can write a into a into a. So we can write z is equal to delta a upon a plus delta a upon a. This is error in z plus delta a upon a. बराबर? As per this, if a into z is equal to a into b, that means error in z is equal to error in a plus error in b. So if z is equal to a into a, that is a cube, that means delta z upon z is error in a plus error in a plus error in a. So apple plus apple plus apple, it will be 3 apples. So we can write delta z by z is equal to 3 delta a upon a. Okay. So what you can observe here, this 3 power I have taken in the numerator. So that's why, suppose the function is given as p to the power a to the power p, b to the power q, and c to the power r, then error in z can be written as p खाली है ना, p times error in a upon a plus q पण खाली है ना, q times error in b upon b plus r को खाली है ना, r error in c upon c. So this is how we are going to find the errors. So write everything. काय केलं, हे कसं कळलं की p खाली येणार, q खाली येणार, r खाली येणार, इथून कळलं. तर आणखी कुठून कळलं, इथून कळलं. कारण if a into b is there, that means error in z is equal to error in a plus error in b. So that means a cube is there, and a cube can be written as a into a into a. So that can be written as error in z is equal to error in a plus error in a plus error in a. 3 times error, that means 3 times error in a. So हा 3 कुठून आला असेल, हा पॉवर कुठून झालेला असेल, ही सम करायची असेल कुठून कळलं, प्रोडक्ट असताना सम करायची आहे इथून कळलं. ओके, यहां से भी पता चला कि जब यहां पे प्रोडक्ट होता है, सो यू हैव टू यहां पे क्या करना है, ऐड करना है. सो इधर पर क्या है, it is the product of 3 functions a cube a sum of 3 functions. So we can write 3 times error in a, that means this power I have taken the numerator. So here there are 3 powers p q r. So take power p here, q here, and r here, and add the 3 terms. Add the a आणि b जरी असलं, a divided b असलं तरी पण आपण हेच करतो, a multiplied b असलं तरी पण आपण हेच करतो. ठीक है. So hope students you are studying well. Wish you very all the best for tomorrow's test. Thank you.